My name's Dr. Katie Medcalf. I'm Environment Director at Environment Systems, and we've been working for about 18 months on modelling ecosystem goods and services for a project in conjunction with the Countryside Council for Wales. This talk discusses how we can apply ecosystem mapping to spatial policy objectives to identify different trade-offs and benefits. The talk is split into 5 main parts. What is the ecosystem approach? Why do we need a new approach to environmental management? What's the current situation and where have we got to with the modelling? How do we bring the datasets together and demonstrate solutions? And how can we use this approach to further joint working projects together? So what is this ecosystem approach? Well, this slide shows an example of the traditional approach. If an area of land was to be identified as having the potential for development, each of the 3 drivers, environment, economy and society, would be viewed in isolation. So if we were looking at siting a factory, we'd look at the economic benefit, and the environment would only be taken into consideration in terms of constraints. If we looked at cultural needs, e.g. siting a new playground, we'd be looking at the interaction of people, and we'd not necessarily take into account how it would work in the economic and environmental sectors. Focusing on only one driver can lead to problems with the others. The ecosystem approach simply brings the 3 sectors that you need to consider for any development together into an integrated way that gives equal importance to environmental management, economic factors, and each community's aspirations. The key objectives of the ecosystem approach are outlined in the Convention of Biological Diversity, which is an internationally legally binding treaty to sustain the rich diversity of life on Earth. The United Nations has declared the period from 2011 to 2020 as the UN Decade on Biodiversity. There are 3 main objectives to the treaty: sustainable land use, which means the economic value of the land; conservation of biodiversity, which we can think of in terms of environmental gain; and fair and equitable sharing of the land, meaning the society's benefits from a block of land. So what are ecosystem goods and services? As part of the ecosystem approach, a conceptual framework known as the Millennium Ecosystem Assessment describes what we call ecosystem services as being the services provided by the natural environment that benefit people. The green box on the left of the diagram shows the different concepts of the environment. For instance, a block of woodland might indeed be used for fuel and wood products, but it will also have a role in providing fresh water. These are called provisioning services. A woodland also has a regulating role. Trees intercept rainfall, they slow it down. They're tremendously useful, particularly in high intensity rainfall events, and this would be called a regulating service. Woodlands also offer huge cultural services. People very much like to spend recreational time in woodlands. So these 3 provisioning services are underpinned by supporting services, and there's an interaction between each of the services. The supporting services are by far the most difficult to map because they require extra scientific evaluation of the datasets available. The ecosystem services themselves help to form the constituents of our well-being, which is described in the blue box on the right of the diagram. These include issues such as personal safety, basic material for good life and health. And there's an increasingly recognised relationship between cultural and regulating services and health, and our good societal relationships. And it's when all these are interacting with and for each other that ecosystem goods and services concept comes to the fore. Why are these concepts important? Well, let's take an example. Here we have a woodland on a hillside and a severe rainstorm event. Maybe we wanted to fell the woodland. If we hadn't done so carefully and we hit a high rainfall event, we might get significant soil erosion. It takes about 2,000 years for soil to form. If it washes off the hillside, it's a bad outlook for that particular block of land, but it's also a very bad outlook for the river because it could significantly make the flooding a lot worse. Flooding obviously has a huge impact on social and economic losses. So people do indeed need the wood products from trees, but they also need clean and fresh water, and they need to be protected from floods. So all of these features need to be considered when felling a block of woodland, not just how can we get the wood out with the biggest economic benefit. How does integrated land management fit into the ecosystem services concept? Integrated land management and ecosystem services consider everything holistically. So ecosystem services are in fact underpinned by integrated land management. Take this example of Aberystwyth. If we're thinking of a new development in this valley, one would need to consider the economic, society and environmental effects all at the same time. As we look at the landscape as a whole, we can see it's giving us our renewable energy through the turbines on the hilltops, our water regulation by preventing rapid runoff through interception of water on the woodlands on the hillside. It's providing pollination material by people having gardens and allotments, and it provides natural flood defences. One might think, if one was planning a development here, that this playing field to the right of the picture would be an ideal part of development land, particularly as it's flat on the outskirts of town near a main road, and there's another playing field just the other side of the school building. However, a playing field and cultural use is only one factor of this particular block of land's usage. Its main factor in the winter is as a natural flood storage zone. In a high rainfall event, as anyone who's passed through Aberystwyth will see, this playing field's normally under about 2 foot of water. In fact, this playing field is responsible for keeping Aberystwyth flood free. Developing the land would not only be bad for that particular development, but it would be bad for the rest of Aberystwyth, and any economic gain which would have been short term from having the development there would be lost year after year in clearing up flood damage. So why do we need a new approach to environmental management? The opportunity for ecosystem services to have developed over the years based on the sharing of knowledge between disciplines and the ability to merge and integrate different data sets. This has become available mainly because of the implementation of high-capacity computer programming. In fact, even 2 years ago, I don't think we would have had the computer capacity available to enable us to do the complicated mathematical joining we've needed to do on these large spatial data sets. But the final factor of ecosystem services that we need to consider at this stage of the talk is the scale of the analysis. When we're considering ecosystem services, it's important to consider the scale at which we're working. For our previous example, flooding in Aberystwyth, it's perfectly sensible to take the small area around Aberystwyth and look at the water movement through it. However, if we're looking at the flood defences as catchment as a whole, we might want to go up onto the top of the Cambrian Mountains and look at the state of the peat there and how that's holding the water back. When we consider the Cambrian Mountains and their effect on water storage, we then have to go on a much wider scale, as the Cambrian Mountains are responsible for water for Shrewsbury, Birmingham, Wolverhampton and indeed into Manchester and North Wales. So the scale of the feature is important. We've been looking at 3 different scales during the 18 months we've been modelling. We started by looking at the East Wales Spatial Plan Area, then we looked at Wales as a whole, and we're currently looking in detail at Bridge End Unity Authority to examine synergies and trade-offs. How far have we got in visualising the ecosystem approach? Well, we had to be very pragmatic and practical and develop a methodology rather than a finished result, because we needed to do what we could with the data we had available. Of course, when you're trying a new block of work, it's wonderful to be able to think, now what data do I need and how would I go out and get it? But in the current economic climate, that option just wasn't available to us. We had to be much more practical and say, what can I deliver with what I have available? The advantage of doing this approach is that gaps in knowledge become clear, and the way of filling these gaps becomes apparent. The practicalities of mapping the existing data sets together was something we had to work out, and we had to do that by developing a set of rule bases and GIS analysis techniques. The rule base was developed to get the most out of the data sets we had. For this example, we're looking at soil carbon storage. And we had the 1 to 200,000 scale soil map. We had the moderately scale but fairly old habitat map for Wales, although in certain areas that's being updated. And we had some land use basic data. And we put these together to make a model of the effectiveness of soil carbon. So how did we do this? We took each individual soil type. We worked out its carbon its intrinsic carbon value, and then we worked out how and where the different soil types interacted with vegetation. For example, if you have a peat-forming soil and the vegetation on it is actively peat-forming, then that's going to score higher than where the peat-forming soil has a degraded vegetation on it, which isn't anymore part of an active peat process. So by calculating these features together, we were able to model soil carbon across the whole of Wales. This is the soil carbon map, and it looks very sensible in terms of what's known about the distribution and uses of soil in Wales. So the peat-based soils of the mountains and the lowland raised bogs have the highest carbon resource, and the sandy-best agricultural soils have a low carbon resource. When we look at agricultural intensity, again we're modelling similar data sets, but using a different rule base, because here we're focusing on the potential of the land for agriculture to show how much could be got out of that land. So the very low intensity areas are forestry and urban, and the higher areas support intensive cropping, and these are in the southeast and northeast of Wales and along the coast. This map shows water regulation. This depends on the interception of vegetation, and we've modelled this data set based on soil type, vegetation type, slope and rainfall data. The livestock density map is at a completely different scale. Livestock's difficult to model when you're just considering Wales as a unit, because individual livestock farms can get stock from in England, sell stock to England, move stock extensively around within Wales, and buy and sell feed maybe as far away as Europe, and indeed most Welsh sheep are sold down to Spain. So looking at livestock density, you can see that the scale of the mapping's gone up, because Wales is actually just a small component of a larger whole. So the whole idea of these initial data layers was to have them as basic searchable layers which could be referred to by policymakers for them to get an idea of the different services being offered by the land of Wales. So managing our land and sea, is it a matter of societal choice? Ecosystem goods and services would say it is, and the more participation the better. This is because of the intrinsic value in intangible benefit question. People very much see their own environment as how it's important to them. Every person would see it a little differently. So if one was looking at a major development in a particular town or community, not only would it be important to have the government officials, but also the people from that local community and the society groups representative. The more people work together and are involved, the better the ecosystem services analysis will become. Do we need an ecosystem approach in Wales? Well, Welsh society is pushing ecosystems to the limits. Wales might not be at the stage like Uzbekistan, where the development pressure on the land was so great that it destroyed their soil and water results and whole communities have had to move. Nevertheless, we are facing pressures, and it's only when we consider all aspects together, environment, economy and society and cultural needs, we will be able to solve some of the challenges coming up. Some of these key challenges are to identify how to manage multiple ecosystem services across the landscape. And in order to address that question, our latest piece of work has been based on Bridgend, and it's been looking at how we bundle interactive information together to gain us integrated knowledge. We've taken three main objectives from the ecosystem approach: the sustainable land use, which equates to economic benefit, conservation of biodiversity, which can be considered environment benefit, and fair and equitable sharing, which equates to social well-being. For each of these three factors, we've examined the components that contribute to their makeup and the features that depend on it. So let's take economic development. Well, for economic development, you now need land with the potential to be used, and that use depends on and is dependent on suitable markets, suitable transport and telecommunication link, together with a skilled workforce. And by using these four subheadings, we've tried to amalgamate the knowledge of information we have about economic benefit together. Similarly, with environment benefit, it depends on and is dependent on genetically viable populations, which are in turn dependent on and depend on the network of habitats, the sustainable land use, and where you have management suitable to help these features. For society benefit, you need food, you need recreation, you need the spiritual well-being that the landscape provides, you need healthy people with employment and security, and all these factors again relate to and from each other. Let's focus a minute on the conservation of biodiversity. By using these 4 subheadings, I'm going to take you through the environment benefit example and explain what we did in more detail. When we consider the network of habitats, the natural ecosystem occur throughout the Welsh landscape, and that they're at their best when they're close or adjacent to other natural habitat. This allows populations to move between habitat patches, retaining their viability. The insects can move from one area to another depending on what's flowering, so rather than just having 2 to 3 weeks of the year when the maize is flowering to pollinate, they have all the wild flowers that come up at different times of the year, so that they're at a strong population density when the maize comes into flower. This enhances and maintains the environment. Without this sort of interaction, you can't get allotments to be productive, and your sustainable land management is considerably weakened. And countries such as the Netherlands and America are reporting on this now, where they're having to introduce artificial pollination strips with a wide variety of seed-bearing plants that flower at different times of year, just to maintain their crop health. So how do we put information together to show conflicts and synergies? Well, we have all the existing information available to us, and we use the subheadings we've just described to create bundles of information. And we did that by defining another rule base. Within this rule base, we looked at the features which help each other. Those are synergistic, and they have an additive effect, and the features which are conflicting. So take the example of environment benefit I've just described. Intensive land management to the benefit of the bundle as a whole would be considered a conflict, because more intensive the land management, the less the natural populations occur and the natural habitat you have available. This would be considered a negative effect and scored accordingly, whilst areas being part of an existing network or existing site of designated importance would be considered a positive effect, considers the synergy and therefore added rather than subtractive. So, how do ecosystem services provide an environment benefit to society? If we look at the network of habitats, we evaluated as being highly responsive and highly positive based on biodiversity resource and biodiversity opportunities. Biodiversity resourcing not only considers such things as species density and diversity, but also looks at how long it would take a particular habitat to be restored after perturbation. So it would be positively related to the vegetation and soil carbon, and positively related to landscape aesthetics, as these 3 features contribute to the whole picture of networks and habitats. But it would be negatively correlated to agricultural intensity and livestock density, because both of these features would detract from the environmental benefit. Similarly, for the other 2 features, they have similar relationships but different connotations and slightly different interactions. We found that a good way of displaying these relationships was by using an exploded pie chart, the scale of the relationship being demonstrated by the size of the pie segment. The large effect would be represented by a large segment, whilst a small effect would be represented by a small segment, the direction being indicated by colour. Green effects are positive, red effects are negative, amber effects have both positive and negative elements in them. Indeed, we used a high, moderate and low approach to set the segment size. So by building the rule base like this, we can score each area, and for Bridgend we can begin to map spatially what this looks like on the ground. So let's go and have a quick look at Bridgend before we go further. This picture of Bridgend shows areas important for biodiversity and water regulation. Cemeteries are important for biodiversity as they're often species-rich grassland and not intensively managed with fertiliser, so they tend to have a wide variety of species. Of course, riverine woodland is also an important resource. Gardens provide pollinator resource but also need a pollinator resource, and you have allotments which are good for local food production but also for cultural and spiritual well-being. There is a role that urban trees play not just for carbon storage but for water and climate regulation, and the role of urban trees is increasingly understood. In terms of culture, you have the recreational resources. So by putting the bundles together, we have our network of habitat maps, our genetically viable population map, and our sustainable land management map. All three can be added together by using a GIS modelling process to give the final environment benefit example. Model data layers shown in this map are in line with expectation based on known observation and research data. The large upland heathland and woodlands are shown as important. Indeed, the wetlands along the M4 are shown as an important resource as well. What is interesting, especially doing the analysis, is the positive information for the urban area. This is something we'll need to address in the next phase. We need to know more about parks, allotment gardens and urban trees. Coming to evaluate the trade-offs. So this map is the same map for economic benefit as we've just seen for environmental benefit, putting all the data layers together. It does show the highest opportunities where the darker colours are. And the same can be done for both environmental and society benefits. So for example, if one needed to site a new factory along the M4 corridor, one could consider what it would look like in each map in terms of that benefit. So along the M4, the wetlands in an old way of thinking, or the traditional way of thinking, may seem to be attractive and ideal for development. They're not particularly aesthetic pleasing. They can look untidy because a lot of the grasses die off in winter, but the leaves stay within a sort of dead mat on the ground. Actually, they're an incredibly important resource for pollinators. And without these sites nearby, maybe the allotments would start to suffer. There's plenty of land along the M4 corridor with high development potential, which is not high in environmental benefit or in societal choice benefit. So the whole concept is very pragmatic. And what we have to work with is what information is available at the moment. And we can put this together to demonstrate to policymakers, society and community groups how you can make changes and decisions based on all the knowledge together. But we do need to add that society commitment into the process. Evaluating new situations, maximising benefits. This diagram shows an example of that. To the left of the slide, we have the old-fashioned way of thinking of it, where we're looking at optimising economic benefit. We put the development on a wet grassland, and the environment benefit is disadvantaged, shown by the downward pointing arrows. Economy is largely advantaged, apart from the part of economy which includes the market gardens, due to a reduction in the pollinator resource. Society well-being received a mix of effects. You know that you're looking at a development to optimise benefits here. When you know what you're looking at, you can develop to optimise the benefit. You can negate environmental disbenefit and place your development on an area of land where it's not going to have such a marked effect. You still have the economic benefits, the well-being benefits, but you've taken away the negative environmental benefits. This is all about economic revitalisation and smart, sustainable economic growth. We have looked at several scenarios, and I'll just take you through one of them, which would involve identifying where to fell woodlands to maximise benefits to biodiversity and recreation. So again, we develop bundles of the various layers. We put these together within a biodiversity area. Then we looked at the network of habitats, which is a Welsh level map layer, which has been worked on by Jim Lathan and Jan Sherry of Countryside Council for Wales. Within the networks of heathland, we were able to use our bundle model to show which particular heathland areas could provide the highest opportunity for the felling of woodland to encourage native heathland resource. How can we use this approach on the ground? Well, the important message from ecosystem goods and services is to think of the wider connotations and consider not just the economic but also the environmental and society effect of any decision which is being made. To use existing knowledge to understand how ecosystems interact. Yes, it would have been lovely to have money to collect new data set, but our challenge was to work with what we have at the moment in a pragmatic way to get the best from our existing knowledge. Where it's essential to collect new knowledge, for instance urban trees, we know a layer is being collected relating to this, and this will add significantly to the models when it becomes available. So let's use the ecosystem approach to work more effectively together. Thank you very much for listening.